Lightning is weird. Whether it's scampering across the sky, taking bizarre, unlikely paths, or even jumping from the ground into the clouds, lightning can do some pretty weird things. However, the most mysterious electrical phenomena around thunderstorms is found just above the clouds.
Oh, boom, big dancing sprites.
Red Sprites are massive electrical discharges occurring high above powerful thunderstorms. They belong to a strange group of upper atmospheric phenomena called Transient Luminous Events and are some of the most breathtaking sights on planet Earth. In today's video, we are going to unlock the secrets behind the mysterious and beautiful world of these incredible natural phenomena. Possible sightings of transient luminous events date back to at least the 19th century. However, it wouldn't be until July of 1989 that the first were ever caught on camera. Shortly afterwards, the strange phenomena would be named sprites as both a reference to their spirit-like appearance and as an acronym that stands for stratospheric perturbations resulting from intense thunderstorm electrification. They come in a myriad of shapes and sizes, ranging from the smallest column sprites to the massive jellyfish, stretching for dozens of miles across the sky. No two sprites are ever exactly the same, as they take on shapes resembling trees, carrots, angels, pillars, jellyfish, or something else entirely. These magnificent phenomena are thought to begin as a result of intense lightning activity in the thunderstorms below. Under special conditions, thunderstorms may grow upscale into massive complexes called mesoscale convective systems. These powerful storms can stretch for hundreds of miles across the sky, producing torrential rainfall, damaging straight-line winds, tornadoes, and nearly constant flashes of lightning. On the backside of these massive thunderstorms exists an area of lighter precipitation called the trailing stratiform region. Within this area, horizontally layered charge regions create some of the largest and most erratic lightning discharges found on Earth. On occasion, these spectacular lightning discharges will branch downward and connect to the ground in a blinding flash of light called a positive cloud-to-ground lightning strike. These massive discharges are the most powerful lightning strikes found on Earth, reaching temperatures of 50,000 degrees Fahrenheit, shifting massive amounts of charge and creating deafening explosions of thunder. As these massive lightning strikes fire, an enormous amount of positive charge is shifted into the ground below, with an equally massive amount of negative charges shifted into the top of the thunderstorms above. This shift in polarity generates a strong electric field between the now negatively charged tops of the storms and a large area of positively charged particles 80 kilometers above in the lower ionosphere. This new charge imbalance causes the air in the upper atmosphere to ionize and undergo electric breakdown, exciting the air and allowing for the flow of a powerful electric current between the tops of the storms and the lower ionosphere. This excitation of air releases energy in a beautiful flash of light and color we call a sprite. Now that we know how sprites form, let's discuss what gives them their incredibly vibrant appearance. What color these sprites appear as depends on what gases they are traveling through and the atmospheric pressure at those altitudes. Because our atmosphere is made mostly of nitrogen, which glows red at the high altitudes that sprites occur at, sprites appear mostly red to us. However, under more powerful events, sprites can sometimes generate another type of TLE called a secondary jet. These secondary jets reach much further down towards the tops of thunderstorms, where the increasing atmospheric pressure causes nitrogen molecules to excite more in the pinks, purples, and blues. In rare photos of massive sprite events, you can clearly see the slow change in the color of the molecular nitrogen emission as the pressure rapidly decreases with altitude. It's within these massive sprites that one of the rarest and mysterious transient luminous events can be found. Over the tops of these giants, a faint green afterglow may become visible after the main sprite event has faded. Only recently discovered in 2019 by Paul Smith and Hank Shima, these mysterious green afterglow events are called ghosts, which is an acronym that stands for green emission from excited oxygen in sprite tops. These mysterious green ghosts are thought to be generated by large Sprite events that reach high up in the atmosphere where there's an increasing concentration of molecular oxygen. Powerful Sprites firing below this region cause the higher concentration of oxygen near the tops of the Sprites to become excited and release faint bursts of green light that seem to last slightly longer than the emission from the excited nitrogen, in a process similar to that which causes the auroras. Rarely documented, it's estimated that fewer than 1 in every 200 Sprites are powerful enough to produce detectable green ghosts, and as a result, very little is known about this recently discovered phenomena. While Sprites and their related phenomena are fascinating, they are far from the only types of transient luminous events lurking in the night sky. To find the strangest of these incredible phenomena, we are going to have to venture back towards the core of these powerful thunderstorms. In the updrafts of these behemoths, massive amounts of collisions and turbulence create charge imbalances that result in nearly constant flashes of intercloud lightning. Under exceptionally rare conditions, the turbulent mixing at the tops of these storms can cause one end of a bidirectional intercloud flash to equalize one end of these charge regions before the other end has had a chance to do the same. This can cause one end of the leader network to branch upwards out of the top of the thunderstorm and propagate towards the upper atmosphere. As the leaders shoot skyward towards a negatively charged screening layer, the lightning channel begins to rarefy and change colors from white to blue as the pressure quickly decreases with altitude. This is how the blue jet TLE forms. However, if the rarest of conditions are met, the leaders of these jets can propagate all the way up to the lower ionosphere and make a connection, inducing a surge of electric current that flows from the storm all the way to the edge of space, changing colors from white to blue to red along the way. These beautiful cloud-to-ionosphere discharges are called gigantic jets and are one of the rarest and most spectacular phenomena found in nature. On exceptionally rare nights, with dark skies and powerful storms on the horizon, Sprites and other transient luminous events can become naked eye visible. On June 17th of this year, the stars aligned in western Texas and produced one of the most breathtaking displays of Sprites I've ever seen.